So today we're going to do systems that have multivariables, so more than two. See? You see it? Let's see. We have an x, a y, and a z. You can do this graphically. We are not going to do it graphically, but I do want to just talk about graphically how you can have an x, a y, and a z. All right, so you guys know x and y. Oh, that's not straight. X and y, right? That is two-dimensional. You add in another axis, that's going to take z and go like this. You see my z-axis? It's the actual marker. Do you see it? Yeah, it's now 3 dimensions. It's x, y, and z. That's 3-dimensional. So if you were graphing with x, y, and z, that would be 3-dimensional. A real-life example of where you would see x, y, and z axes coming together in the origin is that corner, that top corner or bottom corner of the roof. That's x and y, z coming together. So that's how you would graph in space. You're going to have 4 homework questions. 2 of them are like this one. This one, if you look at the equations, I already know what z is. Z is 2. Like on my graph, you don't have to graph it. I'm just showing you. Z would be 2. So somewhere where z is 2, we also have to find x and y. If z is 2, though, I can just back substitute that in right here. So y plus 6 is 5. So y has to be -1. And if I already know that z is 2 and y is -1, I can just plug those in the original top equation. Oops, I put that on the top. For y and z. So I'll have x minus 2 times -1 plus 3 times 2 has to equal 9. X has to equal 1. So when we were doing 2 variables, how did we write our answer? Don't give me this. You just turned in homework where you did it. An ordered pair. So now when we had 3 variables, you write it as an ordered triple. Like x, y, z in parentheses. So our final answer would be 1, -1, 2. That was the x, the y, and the z. There's our x, our y, and then they already do this. Yes.
Could you graph in the 4th dimension?
Yes. No, but yes. Yes. When you go to college and you take higher level calculus classes, you will have 4-dimensional graphing of it. For the 4th dimension is time. Time. So like things can move in 3-dimensional, like a car would be traveling, and then the 4th dimension has to do with the time that it's traveling.
That is crazy.
Oh, that's the highest I can remember going in college was a 4th dimension. I know that there are more dimensions, but I don't know what they are. So the highest I got in college was 4th, and that was to get a degree to teach math. So, all right, one more example. This one isn't as easy. We don't already know what one of the variables is. This is where you need to stay organized. Stay organized, stay organized, stay organized. I taught this in Algebra 2 this year, and the most problems that people have had is not staying organized. First thing I would suggest you do is go over here and say this is going to be equation 1, equation 2, and equation 3. Because then you're going to refer back to these equations, and we have to know which one you're talking about, which one you used. Let's just label them. Our goal is to change this into something that we've been doing, where we have 2 variables and 2 equations. That's our goal. Right now we have 3 variables and 3 equations. We are going to take that and use elimination so we have 2 variables and 2 equations. That's our goal right now. You can't do more than 2 equations at a time. So we're going to pick 2 equations. And we're going to do elimination to get rid of one of the variables. So look at equation 1, 2, and 3. Which 2 equations could we add together and maybe eliminate one of the variables right away? 1 and 2. So let's go ahead and write equation 1 is x minus 3y plus z equals 2. And equation 2 is 2x plus y minus z equals 5. It is very easy to make silly mistakes on this, and you're going to get through all your work and you're going to realize you've done something wrong. Then you're going to ask if I can help you find your mistake, and if your work is not organized, I am not going to do it. All right, I need to be able to follow your work, so please take good notes so you have something to follow. All right, we're going to add those together. The z's cancel out, and we get 3x minus 2y equals 7. All right, so I have one equation with 2 variables. I need 2 equations with 2 variables. So I'm going to do the same process again. I have to eliminate the z again so I can only have x and y left over. It doesn't matter what variables you're eliminating as long as you eliminate the same one twice. So I'm going to eliminate z again, but I can't use equations 1 and 2. I just use those. So I have to use a combination of 2 different ones. I could use 2 and 3. I could use 1 and 3. 2 and 3? Okay. So if I use 2 and 3, can I just eliminate z as is? Multiply 2 by 3. So I've got equation 2 now as 6x plus 3y minus 3z equals 15. And then equation 3 is x plus 4y plus 3z is 13. So 7x, I'm going to do a different color. 7x plus 7y equals 28. It's very easy to make a silly mistake. If I do it, please tell me before I keep working through stuff, because it could happen. All right, so now we have 2 equations with 2 variables. We're going to put those on top of each other. Can I add those up and eliminate either my x's or my y's? Not yet, but I could multiply to do it. So now we're doing the same stuff we've already done. What should we multiply the top one by and the bottom one by? 7 and 2. 7 and 2. Or were you going to say negative 3? Is that what you're saying? Either. You could do it that way too. We just eliminate different variables. All right, what am I going to get? I'm going to have 21x minus 14y plus 49. 14x plus 14y. If I add them up and I get 35x is 105 divided by 35, and that is what, 3? So we know one of the numbers, we know x is 3. Once you have one of the numbers, we're going to take that one that we know and put it in an equation that only has x and another variable in it. So we're not going all the way back to the beginning yet. We're going to take that x equals 3 and put it into one of these two equations, because those have just x and y in them. So I'm going to put it into one of those two. Top one, the blue one, is that okay?
Yeah.
It doesn't really matter, so. 3 times 3 minus 2y equals 7. So y is 1. And then if I know what x is and I know what y is, we're going to go all the way back to the beginning and we're going to plug it in. So I'm going to, you guys can see the equations. I can't. I have to keep scrolling, so I'm just going to scroll it down and use my notes wherever they went. Maybe. Okay, so we're going to plug in x is 3. I'm just going to use the first equation. 3 minus 3 times 1 plus z equals 2. So z is 2. Is that true? Plug it in the second equation. 2 times 3 minus 1. No, plus 1, minus 2 equals 5. Is that true? Yes, that checks. So do I know I have the right answer? No, I don't know that yet. There's 3 equations. You got to check them in all of them. Okay, I do them all. One more step. It's okay. You only have 4 equations for homework. So then my last one, I'm going to type or plug it in. I'm going to plug 3 plus 4 times 1 plus 3 times, what's the 2 equals 13. And that checks. So what's the answer?
3, 1, 2.
In parentheses with commas, same way you do in ordered pair, only in ordered triple. Okay, so when you do your assignment, take your time, stay organized, ask questions. I will just tell you, because potentially the first time that you're doing this ever or in a long time, while we can get, horrible fractions in real life, your homework might have fractions, but they're not horrible fractions. So if you're getting stuff like 13 over 7, crazy fractions like that, probably do something else. Okay. There are fractions in the answers, but they're not horrible. They're more like, what's a good fraction? 3/4, 1/2, 7/8. Not even that big. I'm just telling you so you have some confidence, like you know you're doing it right or not. Okay? Grab a book, you got lots of time. Here's the assignment. Grab a book, you got lots of time. We are not sitting here talking for the next 30 minutes. We are doing the 4 questions in our homework.